Hello, my name is Tomo Wilkens, and I will be discussing the CPM calculations in three different parts. I've been involved in the scheduling profession since the late 70s, and I was also a member of the core team for the original scheduling practice standard for PMI. Knowing how your scheduling tool calculates the activity dates can help you understand where the dates come from, and sometimes why they are not what you expected. This will help you develop better schedules, which in turn will help you communicate more clearly with your stakeholders, not to mention have better control over your project execution. This presentation will go step by step through the computer's algorithm and thereby give you the full understanding of why the dates are what they are. In this presentation, I will focus on four key variables that every project manager and scheduling practitioner should know: early dates, late dates, total float, or slack as it is sometimes called, and free float, or slack as it is sometimes called. Now, the CPM calculation proceeds in what are known as two passes. The forward pass establishes the early dates. And if you can imagine the activity bars on your bar chart, try to slide as far to the left until they bump into one of three things: either the project start date, or the current data date, or status date, or a predecessor activity's early finish date, or a not earlier than constraint. And the computer calculates activity dates from start to finish, or left to right. And that, of course, is why it is called the forward pass. We have this very simple network of 5 activities. And so activity A slides as far to the left as it can, since it has no predecessors. Activity B slides as far to the left as it can until it bumps into its predecessor. Activity D, which also has no predecessors, slides all the way to the left. Let us assume there is a start not earlier than constraint on activity E. So activity E slides as far to the left as it can, but it will not reach its predecessor, activity D, because it is prevented from sliding further left by its no earlier than constraint. And then activity C, which has 2 predecessors, slides as far to the left as it can until it reaches the first predecessor, that is, the one that sticks out the furthest with the latest date. In other words, the finish date of B is later than the finish date of E. So C stops moving left when it bumps into activity B. That's basically how the activities are scheduled. Now let us look at more detail of the calculation. So we have the same simple little network here, but I did not include the not earlier than constraint on activity E. So the letters, of course, are activities A, B, C, D, E. The numbers in the yellow boxes represent the duration in days. So the computer starts to calculate and looks at day number 1, the first day in the schedule. And it determines that there are 2 activities that have no predecessors. So it finds activities A and D. So for activity A, it says the start date must be day number 1, because that's as far to the left as it can slide. Now, to come up with the finish date, the computer does not see the graphics. You may be counting the days and say to yourself, well, activity A is going to finish on day, let's see, day 1, 2, 3, 4, 5, but the computer doesn't see the graphics. The computer only knows certain information. And the information the computer knows is the activity ID, its duration, its predecessor relationships, any constraints that might be imposed on some activities, and any lags that might be in the schedule. And we're not going to be looking at lags for this simple demonstration. So the computer uses a formula to calculate the finish date. And that formula is that the finish is equal to the start plus duration minus 1. Now, the minus 1 is there because the dates are counted inclusively. Days 1 through 5 are all working days. So there is another convention that some schedulers prefer, and that is called the noon convention, but the much more common one is the AM-PM convention. So if we look at activity B, it slides all the way to the left until it bumps into A. Now, with the AM and PM convention, activities always finish at the end of the working day and they start at the beginning of the working day. So the dashed lines separating the days effectively represent the nighttime hours on a normal working project. So if activity A finishes on day number 5, activity B must be starting on day number 6, the next morning. Now, applying the formula again, start plus duration minus 1, we get 6 plus 10 is 16, minus 1 is day 15. So now you may be tempted to say that activity C can start on day 16. However, activity C has 2 predecessors. And again, while we see graphically that C is kept from sliding further left by activity B, the computer doesn't know that yet. It needs to evaluate all the dates for all of its predecessor paths. So we need to calculate the green path. Activity D then also starts on day 1. Per the formula 1 plus 8 minus 1, it finishes on day 8. Activity E starts the following morning, which would be day 9. 9 plus 3 minus 1 is day 11. And now we can see that activity C can start on day 16 because it realizes that one of its predecessors keeps it from going further than day 15, while the other it keeps it from going any further than day 11, but obviously the controlling predecessor in this case is activity B. So again, we apply the formula 16 plus 7 minus 1, and we come up with a finish date on activity C of day 22. And this is the end of the forward pass calculation. And these are known as the early dates, the early starts at the front and the early finishes at the ends of the activities. Now let us look at the next stage of the calculation, and that is the backward pass. It establishes the late dates. All activities in this case slide to the right until again they bump into one of 3 things: the project finish date, a successor activity's late start date or a not later than constraint. And it calculates activity dates from finish to start, from right to left. And therefore it is known as the backward pass. So we look again at our little schedule here, and we see activity C slides all the way to the right. And I did not bother to remove that last column, but that is the original date that C finished on. So it goes as far to the right as the forward pass calculated. So activity B is one of its predecessors, and it then slides as far to the right until it bumps into successor C. Activity A slides as far to the right until it bumps into its successor B. Now again, let us suppose in this case we have a finish no later than constraint on activity E. So activity E slides as far to the right as it can until it bumps into, in this case, a not later than constraint. In other words, it doesn't reach all the way to activity C because the constraint keeps it from going any further. And then the predecessor for activity E slides all the way to the right until it bumps into activity E. So here we have the activities shown in their late date position. Let us look at the calculation. Again, I have not included the constraint on activity E, and I have not shown the green activities in their late date positions. So now it is just a little bit more difficult to count spaces to see what the finish and start dates are. So the computer starts to calculate the backward pass. And activity C then slides all the way to the right until it reaches the end of the project, which was day 22, and that day comes from the forward pass calculation. Now be aware, if you do not specify a project finish date, the default that your scheduling tool will use for the project finish is the last date from the forward pass calculation, which is that day 22 in this case. But suppose that we said we want this project to finish no later than day 24 out here. In that case, C would slide further to the right until it bumped into the finish date, which is now specified rather than using the default from the forward pass. Now, if activity C would finish on day 24, okay, then all these other dates would be affected accordingly. But we will continue our presentation and calculation using the default project finish date. Now the computer uses the same formula that you see up there in blue to calculate the start date. But we simply flip all the terms to the other side of the equal sign. Okay, so we solve for the start and we bring the plus duration and minus 1 to the other side. So we have the start is equal to the finish date minus duration plus 1. And the plus 1 again because we're using inclusive days with the AM/PM convention. So we calculate the start date now for activity C, which then is the finish 22 minus 7, which is 15, plus 1, and so we come up with day 16. Activity B slides all the way to the right until it bumps into its successor, and again with the AM/PM convention, if activity C is going to start on day 16, activity B better finish on day 15. Per the formula, 15 minus 10 plus 1, and we come up with 6, and therefore A needs to start on the day before that, which is day 5. 5 minus 5 plus 1 gives us day 1. Now you notice here for the red activities, the early dates and the late dates are the same, and I will explain that in a moment. Now, activity E also has a late finish date, which is the day before its successor start date. So the late finish for activity E is also day 15, because if E were to finish any later than day 15, it would impact activity C. So by the formula, 15 minus 3 plus 1 gives us 13, in which case D needs to finish by day 12, and then 12 minus 8 plus 1 gives us 5. And these are known as the late dates. So we have the late starts over here, and we have the late finishes over here on the ends of the activities. And so we're now done with the forward pass and backward pass calculation. Now you might ask, so what? What's the big deal? And why do I care about early dates and late dates? Well, let us go on and consider. Total float, or total slack, as it is known in some areas, indicates how much spare time activities have without delaying the project finish. I'll say it again. The spare time without delaying the project finish. And it is typically the difference between the late finish date and the early finish date. In my philosophy, the total float belongs to the project manager, not the individual team members. And this will become a little bit clearer later on when we talk about the next topic. And now let us take a look at the float calculations. Total float is equal to late finish minus early finish. So you see all the late dates on the bottom in red and the early dates on the top of the bars in blue. So the total float for activity C would be the late finish 22 minus the early finish 22, and that would be 0. Similarly, for activity B, we have 15 minus 15, and for activity A, we have 5 minus 5. Now, activity E, we have late minus early. So late is 15 and early is 11. So activity E has 4 days of float, and activity D also has 4 days of total float, 12 minus 8. So there we have the total float calculations from the forward and backward pass. Now what that means is that if you have no float, any delay in your activity will push the project finish out. So consider activity A, B, or C. If any of them extends by 1 day, that would push the successors out beyond their original dates, and the project finish would also be pushed out. Activity E can slide 4 days, 1, 2, 3, 4, before it starts to impact activity C, its successor. If it slides 5 days, more than its total float, then activity C would be pushed out accordingly, as would the project finish. Similarly, activity D, if it were to be pushed out 4 days, it would push activity E along with it, but still would not impact activity C. If activity D were to be delayed 5 days, it would push E out 5 days as well, and activity C and the project finish would be impacted accordingly. Now the total float is cumulative for the various paths. So for example, if activity D extended by 3 days, it would push activity E out by 3 days, and there would still be 1 day of float left. But now if activity E also extends by 2 days, it would push activity C out by 1 day, and project finish would be pushed out. So that is how the total float works. Now we're going to consider another aspect of float, and that is called free float. Free float is the difference between the successor's start and the predecessor's finish. So if we look at activity E, we notice there's a difference between the predecessor's finish and the successor's start. So activity E would have some free float. Let us take a look at what it means. Free float indicates how much spare time activities have without delaying any successor activity. So again, spare time without delaying any successor activity rather than the project finish date. It is the difference between the successor's start and the predecessor's finish. So if there's no gap between those two activities, then there would not be any free float. And again, according to my philosophy, the free float does belong to the team member, not the project manager. Let's consider what this really means. So here we have another network with a few more activities, and I've listed the total float and the free float in the two columns on the left. You will notice that in some cases, the total and free float are the same as here, the 0, 0 or 7, 7, but the total float and free float can be different, as we see here with the 7 and 0 or the 9, 0, 9, 2. Now, if you look at this, you will notice the only two activities with any free float are activities F and H. And you can see by inspection on the bar chart that sure enough, between the finish of H and the start of its successor, there is some slack time or spare time here. Similarly with activity F, between its finish and its successor start, there is some spare time. If you look at all the other activities, the relationship lines are straight up and down vertical. There is no horizontal component as we have for F and for H. That means there is no free float. So the moment A slips any bit at all, it would impact its successor. The moment D would slip any at all, it would impact its successor. The moment E would slip any at all, it would impact its successor. Well, now you might think, so what's the big deal? Suppose you're working on activity E and you're realizing you're running into some trouble, but you're not worried because you have 7 days of total float. If E pushes out 7 days, it will push F along with it, but still not impact activity C or the project completion. So if you're on E and the project manager starts hollering at you, you might say, hey, get off my back. I've got a bunch of total float. What's the problem? Well, the problem is that the resources that were planned for activity F, and as for all the activities, right? But for activity F, they were planned to be conducted on days 12 and 13. And if E slips at all, it's going to impact the resources on its successor. Maybe the resources on this successor, whether it's labor or equipment, okay, are specifically planned on these 2 days, 12 and 13. And if that is impacted, it may have an impact on what these resources were going to do further down. Let me put it into dollars and cents. Imagine activity F involves the rental of a crane. So you contract with a rental company and they give you a contract and they say, okay, we'll deliver the crane on day 11. You use it on the next 2 days and we'll dismantle and pick it up on day 14. And for that, I will charge you $1,000 a day. So you have a $2,000 rental bill. But the contract also says, if there is any delay in returning this crane to me, it will cost you $5,000 per day of delay. So suppose E extends by a day and F has to get pushed out a day accordingly, you will be paying $7,000 for that crane rental because the crane company is going to say any delay is going to cost you $5,000. So you're paying the $2,000 for the 2 days rental plus the $5,000 for the delay. And there's good reason for the equipment rental company to do that, because they have that crane scheduled for another customer, another job site. And if you're delaying the usage, you are impacting their reputation, or at the very least, their ability to satisfy other customers. And for that, they're going to make you pay. So it is important to look at free float as one of your primary indicators of what kind of flexibility you have in the project. Free float shows when successors are impacted. These successors have resources scheduled and committed for a certain time frame. Exceeding an activity's free float upsets the successor's resources. And I promise you, manage the free float and your project is guaranteed to finish on time. Now, I will say that the free float value is probably the most neglected and perhaps misunderstood variable that comes out of your scheduling tool. I have found many scheduling practitioners who don't really understand free float. Now, hopefully you do and appreciate its importance. It gives you a whole bunch of information about your project. I hope you've enjoyed this presentation. Please feel free to send me comments on my website. I'd love to hear from you, and have a wonderful day.